Next, let us consider addition of 2 points on elliptic curve. So in the previous video, we have observed that we can able to find a group that is E7 of 1, 1, and here these are the field elements. Let us use the same field and add 2 points in the field. So I'll just copy these things. So here the elliptic curve group is E7 of 1, 1, and the corresponding points are, here what were the points? The points are 0, 1, 0, 6, 2, 2, and 2, 5. So we are going to get 0, 1, 0, 6, and 2, 2, 2, 5. So these are the elliptic curve points. And one thing you can notice that here the value of x coordinate is same, but y coordinate is 1 as well as 6. So what it indicates is, if I add 1 plus 6 and then I take mod 7, what I am going to get? 7 mod 7. 7 mod 7 is nothing but 0. So when I add these two numbers, field elements, I am getting the additive identity, means 1 is the inverse of 6 and 6 is the inverse of 1. So if I consider this as point P, then this will be minus P. And similarly, when I consider these 2 points, okay, 2, 2 and 2, 5, here we can see that x coordinate is same, y coordinate is 2 and 5. So if I add 2 plus 5, again it is 7, and 7 mod 7 is 0. So this indicates that 2 is the inverse of 5 and 5 is the inverse of 2. So if this is P, then this will be minus P. So we can observe that whenever a point exists, its corresponding inverse is also, so its corresponding additive inverse point is also present on the curve. Similarly, here also. Okay. And now let me select addition of P and Q. Okay. Let P is, let the point P is equal to 2, 2, and let the point Q is equal to 0, 6. So now I want to perform P plus Q. So when P and Q are not same, in that case, what I have to do? I need to use this expression to find out lambda. So lambda will be equal to yq minus yp by xq minus xp mod p. So here this is the x coordinate of p. So let I represent this as xp, and this is a y coordinate. So this is yp, and this is xq, and this is yq. Now when I consider yq minus yp, means I need to consider 6 minus 2 divided by xq minus xp, that is nothing but 0 minus 2 mod 7. So now here we are going to get 6 minus 2 is 4, and minus 2 mod 7 means we are going to get the additive inverse of 2, that is 4 by 5. For this we have to consider mod 7. And this can be written as 1 by 5 into 4. Okay. And this is mod 7. And this is nothing but 5 inverse into 4. Mod 7. Now we have to find out multiplicative inverse of 5. Since the p-value is very small, instead of using extended Euclidean algorithm, I'll just try to multiply two field elements and find out for which particular modulus we are going to get the value 1. So when I multiply 5 with 1, I'll be getting 5 only. 5 mod 5 is not equal to 1. So if I multiply 5 with 2, we are going to get 10. And 10 mod 7 is equal to 3. So 2 cannot be an inverse. And if I multiply 5 with 3, it is 15. 15 mod 7 is equal to 1. Okay. So this indicates that 3 is the multiplicative inverse of 5. Okay. So now we can able to find out that 5 and 3 are inverse to each other. So as a result, when I'm going to find out lambda, I'll be considering 5 inverse into 4 mod 7 as 3 into 4 mod 7. So 3 into 4 is 12. 12 mod 7 is nothing but 5. So I'm going to get the lambda value as 5. Using this lambda, I need to find out x coordinate and y coordinate. And we know the expression for x coordinate. So the expression for x coordinate is lambda square minus xp minus xq. So here lambda square is nothing but 5 square minus xp. What is xp? Here we are having xp as 2 and xq as 0. So what we are going to do, I'll just going to consider 2 minus 0 mod p. So here 25 minus 2 is 23. 23 and this p is 7. So 23 minus 7 means, sorry, 23 mod 7 means I'll going to get the value as 2. And next y coordinate, that is yr. What is the expression for yr? Yr is nothing but lambda into xp minus xr minus yp mod p. So here lambda is 5, xp is 2 and xr is also 2. 2 minus 2 minus, what is yp? Yp here is 2. So we are going to get 2 mod 7. Okay. So this whole term will become 0. So we are going to get minus 2 mod 7. Minus 2 mod 7 is nothing but 5. That is nothing but 7 minus 2 is 5. So the y coordinate value is 5 and x coordinate value is 2. So according to that, xr comma yr is nothing but 2 comma 5, and we can observe that 2 comma 5 is also a point in the group. Okay, so that is the reason we are going to call this point as resulting point r, which is 2 comma 5. So when we are going to add any 2 points on the elliptic curve, whatever the third point we are going to get, that is also present in the curve. So that is the reason we are going to call it as abelian group. And the next thing what we have to do is we have to find out 2p. So again here I'll just write down p is 7 and ep of 1 comma 1. This is the group we have considered, and the points are 0 comma 1 and 0 comma 6, 2 comma 2 and 2 comma 5. These are the points, and we took the point p is equal to 2 comma 2. So now when I want to find out 2p, what I have to do? I need to find out, I need to add p plus p. So here I'll going to consider xq xq, which is equal to xp, which is equal to 2, and yq equals yp is equal to 2, because we are in the expression, that is xr, resulting point coordinates xr and yr is nothing but lambda square minus xp minus xq. So here xp and xq are same, and mod q we are going to consider, and for yr it is lambda into xp minus xr minus yp mod q. These are the expression. And what is the expression for lambda? Since we are adding the same point, we will not be considering the slope. We are going to consider tangent. What is the expression for tangent? It is 3xp square plus a divided by 2yp. For this, we will going to consider mod q. Now, from this elliptic curve group, we know that a is equal to 1 and b is also 1. So according to that, I'll just write here lambda equals 3, xp is 2. So 3 into 2 square plus a is 1 divided by 2, yp is also 2. So we are going to consider, we need to solve this expression. So here what we are going to get, 3 into 2 square is 4. So 3 into 4 is 12. 12 plus 1 is 13 by 4. And here we need to take mod 7. So I need to find out multiplicative inverse of 4. That should be multiplied with 13. And then I need to take mod 7. So how to find multiplicative inverse? Since P is very small, I'll just multiply the field elements with 4 and find out where I will going to get mod value as 1. So 4 into 2. So 4 into 4, 4 into 1 is 4. So 4 mod 7 will be 4. So I'll be using 4 into 2 mod 7. Okay, so here 4 into 2 is 8. 8 mod 7 means I'll be getting the value as 1. So this indicates that 2 is a multiplicative inverse of 4. So what I'm going to do here, I'll just take 2 into 13 mod 7. 2 into 13 is 26. 26 mod 7 means I'll be getting the value as 5. Okay, so 26 mod 7 is 5. So we are going to consider lambda as 5. Now find out xr and yr. So xr is nothing but lambda square is 5 square minus xp is 2 and xq is also 2. So we are going to get mod 7. That is 25 minus 4 is 21 mod 7, which is nothing but 0. And we are going to find out yr. Yr is lambda into xp is 2 and xr is 0 minus yp is 2 mod 7. So here 2 minus 0 is 2. The 2 into 5 is 10. 10 minus 2 is 8. So we are going to get 8 mod 7, which is nothing but 1. So the resulting point R is having the coordinates xr, yr as 0, 1. Okay. So when we are going to add a point to itself, the resulting point R is also present on the curve. I've added this point twice, so the resulting point is also on the curve. This is how we can able to perform addition of 2 points in the elliptic curve and point doubling. Point doubling means adding a point to itself. Okay,